going to see on the topic called clustering algorithm. So this is one such kind of unsupervised learning algorithm, that is unsupervised machine learning algorithm. Fine. Okay, the objective of the session is to make you known about the basics behind the clustering algorithm, and the outcome the students may be able to understand the concepts behind the clustering algorithm. Okay, and these are the outlines of today's class. Okay, so let's see what is meant by unsupervised learning algorithm, and under the unsupervised learning algorithm, one of the such classification is that is clustering. Okay, clustering and association rule mining. So yesterday we have seen all about association rule mining. There we have seen two algorithms to find the association rule mining. That is, one is a priori algorithm, the other one is FP growth algorithm, that is frequent pattern growth algorithm. So these all association rule mining and clustering comes under unsupervised machine learning algorithm. Fine. So in that, today we are going to see the clustering algorithm. Okay. So we'll be first starting with the definition part of the clustering. What is meant by clustering, and what are the applications of clustering algorithm? And we are going to compare the classification with that of the clustering, and we'll be seeing what are the types of clustering algorithms involved, and how do we measure the similarity metrics. Okay, and under this distance measure, we are having four types of distance measure. So the first one is Euclidean distance measure, and the second one is square Euclidean distance measure, and the third one is Manhattan distance measure, and the fourth one is cosine distance measure. Okay. Next, we'll be seeing about the types of clustering algorithm. That is, one such type of clustering algorithm is hierarchical clustering algorithm. Next, we'll be seeing under the hierarchical clustering algorithm, we'll be seeing about there are two major classifications under hierarchical clustering. One is agglomerative clustering, the other one is divisive clustering. Okay, and the next we'll be seeing what is meant by a K-means clustering algorithm, and how does this algorithm works, and we'll be seeing the applications of K-means clustering algorithm. With this, we'll wind up today's session. Okay. So starting with the machine learning algorithm, we have started with the overview. That is, machine learning is the process of creating the models which will perform certain tasks without the need of human explicitly programming to do something. Okay. Okay, already we have seen the types of learning algorithm falls in three categories. One is supervised learning, and the other one is unsupervised learning, and the other one is third one is reinforcement learning. Okay. So supervised learning means a teacher will be guiding the students. So best example, that is, supervisor will be supervising the students, like that. Okay, and you will be given some training data sets, and the task of the supervised learning machine learning algorithm is to classify those training data sets. That is, you have to predict the output classes with the given or provided the training data sets. Okay, so you will be given the input training data sets, and you will be known of the output class, how it will look like, or how it can be achieved, like that. Okay, so all will be known to the user. That is case of supervised machine learning algorithm. So under the supervised machine learning algorithm, the classifications and regression will be there. Okay. So coming on to the next is unsupervised learning algorithm. There won't be any guidance for teacher. So no output class is known to the user. Okay, and no labeled data. So it's all these. So unsupervised learning means it is all about a self-learning. Okay, that is in that we have to go for finding the patterns. Okay. So under unsupervised learning, we will be seeing the classification as categories as clustering and association rule mining. Fine. Coming on to the reinforcement learning, it is a different kind of, apart from the rest of the two learning methods, it's a different kind. So reinforcement means the agent will be learning the environment based on the experiences. Okay. So whatever the experiences faced by the agent, he is going to be, or he or she, the agent is going to be rewarded or punished, like that. Okay. So with this short note, we'll move on to the what is when they unsupervised learning. So from this picture itself, we can clearly assess that supervised is nothing but the mission is going to be trained by the guidance or the teacher, that is by the supervisor. So the supervisor will be training the mission. Okay. Whereas in case of unsupervised learning, there won't be any guidance or any teacher or supervisor. Okay. So it is unsupervised learning is thought of as a self-learning, where the algorithm can find previously unknown patterns in the data sets. So there won't be any labeled data or output is unknown to the user. Okay. This is what the unsupervised learning algorithm is. Okay. For example, if you take it, suppose you and your friends want to watch the cricket match, but you do not know how the cricket game will carried out. Okay. So, but for your friends, you say yes. So you reach home and start watching the match. Okay. If this is the scenario, okay. So you do not know what's really happening in the cricket game. You just sit simply as a blank. Okay. But looking at your friends, you want to join for the fun. So you start learning about the game. Okay. So, for example, by observing, you will be learning that there are two teams with the Joshis of colors blue and yellow. Since Dhoni is playing, he belonged to India, you have the score of India on the screen. You conclude that India has chosen the blue and Australia has chosen the yellow Joshis. Okay, and two players belong to India having bats in their hand, meaning the two batsmen playing for India. Like that, so and so observations you are making out. Okay, and there are around 9 players around the field. There are different players in the field. So batsmen, bowlers, fielding, fieldman, wicket keepers, two umpires. So there, the umpires will be managing the match. So this what you will learn. You are this observation made you to learn about the cricket game by yourself without the guidance. Okay. So this what about the best example for the unsupervised learning, that is self-learning. Okay. So we come to the conclusions that there are two teams, India and Australia, different kinds of players such as batters, bowlers, and so forth, or being playing in the cricket game, and ball hits wickets or is caught, batsman is out. All such observations are made by you, and you can also cheer up when India score 4 or 6. So likewise, you are learning by yourself. Okay. So unsupervised learning, why it is so important? So it is the main objective of unsupervised learning is to find the patterns which were unknown. Okay. And the patterns will help in categorizing the groups or finding the association between the patterns. Okay. And they can also detect the anomalies and the defects in the data. So unsupervised learning, they work on the unlabeled data, which makes our work easier. Okay. And coming on to the types of unsupervised learning algorithm, you are having clustering and association. So suppose if you are given a basket full of fruits, okay, Now the task is to group the fruits based on their shapes or colors, whatever may be the features that can taken into account and classify or group into one cluster. Okay. See here we are having three such groups of being made, okay, based on the different colors and shades and the fruit names. Okay. Okay, coming on to the association. So association is all about mapping the dependencies between the objects. Okay. So for example, if you buy the butter and bread, the person may also buy the milk. Likewise, there is some association or the relationship or the dependency, mapping the dependency between the objects or the items. Okay. So this is called association. So these two, association and clustering, all belongs to the unsupervised machine learning algorithms. So yesterday itself we have seen association algorithm, that is how to form the rules, association rules, and what are the measures to calculate the association rules, that is support and confidence and lit. Sorry. So these are all the things we have seen in yesterday for association rule mining. Two algorithms we have seen. Now, under this clustering, we can go for the classification as K means clustering, KNN clustering, and hierarchical clustering. So, under the association rule mining, we have two algorithms. One is called as a priori algorithm, the other one is called as epigrowth algorithm. And these two algorithms are used to find the frequent item sets. So after finding the frequent item set, we have to go for framing or forming the association rule. Then we have to go for check out with the whether you are forming a strong association rule or weak association rule based on the support and the confidence value in the provided the minimum support threshold value and the minimum confidence threshold. Fine. So let's see what is meant by clustering. So clustering means it is the method of dividing the objects into clusters. Okay. So how we are going to divide the objects into clusters? So it is based on the similarity measures. So which are all having the similar properties will be forming a cluster, and which are all having the dissimilar properties of objects will belong to another cluster. So in this way, the objects will be divided into clusters. That process is called as clustering. Okay. See. So let's have a definition that clustering is organizing a set of disorganized objects with respect to the property. So cluster is a collection of objects which are similar between them and dissimilar with the objects of the other cluster. Suppose if you are given different kinds of shapes, okay. Now you need to go for clustering based on the shapes. Okay. Then you could find three clusters based on their shapes. Okay, star, circle, and square or rectangles. Okay. So clustering means it's a process of grouping similar items together. That process is called as clustering. And the clustering should be very similar to each other. So the items should be very similar to each other so that they can form a cluster. And the other cluster will be having different or dissimilar objects will be clustered, will be grouped to form another cluster. Okay. So we can say that intra-cluster intra-cluster similarity between the objects is high. Intra means within the cluster. Within the cluster, we might have some more number of data points. Okay, so within the each cluster, the similarity means the distance between the data points within the one group should be high, and the inter-cluster similarity should be low. Inter means that is the between the other cluster. Okay, that similarity should be low. Okay. So what are the applications of cluster? That is, we can have the customer segmentation, social network analysis, and city planning. Okay. So let's take the example of customer segmentation. So now your objective is to make 3 marketing strategies. Okay. So the input provided is age in years and engagement with the page in days and week. Okay. So you have given some input data of 8 people with your ages and their engagements. Okay. Now the goal is to cluster, that is you are going to form a group based on their ages and engagement. Okay. So then you have to look through the input given or observe the input given. Okay. Now you could find 2 ages, that is age 49 and 51. These people will belong to the age group around 50 with the engagement 1. So 1 engagement in days per week. Okay. So these 2 people will form a one group. Okay. And next you can go for making another group which belong to the age group of 20 and around. Okay. So having the engagements 2, 3. Here also you can have you can also combine age 20 engagement 4 with the along with the 18 age and 23. So this 3 will form another group. Okay. So likewise you need to form a 3 marketing strategies. So this is a plot in which you can group. So this grouping is this plot is between age and the engagement. Okay. So age along the x-axis and engagement along the y-axis. Okay. So find you could find 3 strategies based on their age group and the engagement. Okay. So clustering, the goal of clustering is going to be grouping the data points based on the similarity measures. So this similarity measures will be based on the distance measure. Okay. Okay. Let's see the comparison between the supervised and unsupervised, or in other words, we can say the difference between the classification and the clustering. So under the clustering, you will be given a number of classes. That is, no number of classes will be given to the user. Okay. So no number of classes means classes is going to be your output, the target class, it's labeled class. Okay. But in case of clustering, the label, there won't be any labeled classes or unknown number of classes. See, the output not known, that's the meaning. Okay. And classification is based on the training data set, whereas clustering, there won't have any prior knowledge about the training data set. Okay. And coming on to the next difference, classification is used to classify the future observation, that is the prediction. So this will be the fed output that will be predicted in case of classification. But in case of clustering, it is used to understand the data or understand the data given. So you might gain knowledge out of the output. Okay, that is in case of clustering. So in added to some more points, okay, we can go for comparing the classification and clustering. Classification uses the labeled data as the input, whereas clustering uses unlabeled data as the input. Okay. So in case of classification, the output is known, whereas in case of clustering, the output is not known. Okay. And classification comes under the supervised learning machine learning algorithm, and the clustering comes under the unsupervised machine learning algorithm. And the training data set is provided and used to produce the classification. Whereas in clustering, the training data set will not be provided and it is used to produce the clusters, groups. Okay. An example of classification algorithms for decision tree, we have seen ID3 algorithm in this decision tree, and we have seen Bayesian classifiers and support vector missions. All these comes under classification algorithm. And coming on to clustering, you can classify into partition-based clustering. Under partition-based clustering, you can have the k-means clustering algorithm, and the next second type is hierarchical clustering algorithm. Under this hierarchical clustering algorithm, you might have two types. One is agglomerative clustering, hierarchical clustering, and divisive clustering. And the third type is DB scan. Okay? And the classification will be can be more complex than clustering, whereas clustering can be more complex than the classification. Okay, fine. And classification will be having consisting of two phases. The first phase is the building the model, that is classifier model. The second phase is the prediction. Okay, and in case of clustering, we will be having the single phase alone. Okay, and boundary conditions must be specified in the classification, and boundary conditions do not always need to be specified in the clustering. Okay. And coming on with the types of clustering algorithm, there are so many types or there. See here, it is being clustering algorithm is being classified into hierarchy methods, partitioning methods, grid-based methods, clustering algorithms used in machine learning, algorithms for high-dimensional data. Okay, this hierarchy method is going to be classified into two types. One is agglomerative algorithm, and the other one is divisive algorithm. Okay, so and partitioning methods is classified into relocation algorithms, probabilistic clustering, k-medoids methods, k-means methods, density-based algorithm. Under the density-based algorithm, you are having two types. One is density-based connectivity clustering, the other one is density function clustering. Okay. And clustering algorithm used in machine learning is classified into two types. One is gradient descent and ANN. And the next type is evolutionary methods. And algorithms for high dimensional data is classified into three types: subspace clustering, projection techniques, co-clustering techniques. So I have picked out this slide in some other video, but can have this as a type of string in a nature wherever it can go. We have this types of classification in your clustering type. Okay, so mainly two types: one is hierarchy clustering and partitional clustering. Under the hierarchy, agglomerative and divisive methods, there are two types, and partitional clustering, you are having two types. One is k-means and fuzzy c-means. Okay. Okay. We'll see what is meant by hierarchical clustering. So this hierarchical clustering, we have the clusters. It will form a tree-like structure. This tree structure will be depicting or represents the parent-child relationship. Okay. Let's see what is meant by hierarchical clustering. Let's consider an example. We have a set of cars. We have to group similar ones together. Okay, and we are forming a two cluster of types sedan and SUV. So based on the car types, the groups are made. Okay. Again, at last we group everything into one cluster. Okay. So at this point, whenever you form one cluster, single cluster, we terminate at this point. Okay. Okay. So what is meant by hierarchical clustering? Is nothing but the separating the data into different groups based on some measure of similarity. That is called as hierarchy clustering. Okay. Let's see the types of hierarchy clustering. The first type is agglomerative, and the second type is divisive method. So agglomerative is known as bottom-up approach. It follows the bottom-up approach. Bottom-up approach means from the least level. So if you consider a tree, from the least it has to form the branches, and it has to the combination of nodes, it will form a root. So from leaf to root, that is going to be the bottom up approach. Okay. See here, agglomerative will be following the bottom up approach. See here, it begins with the individual elements. The A, B, C, D, E, F are the each element which will form the separate cluster. Okay. So each data points, we can say it as data points or elements. Each element is going to be considered as a cluster, one cluster. Then again you will be combining the two data points to form a cluster. Then again going on merging the clusters into successively. If you go on merging the clusters, you will form a larger cluster. So this you will get a large cluster. Okay, so this is called as bottom up approach. So agglomerative algorithm follows this bottom up approach. So starts with the individual element as a cluster, and individual elements join to form another cluster. Then the merging process will be taken successively to form a larger cluster. Okay. So coming on to the divisive. So divisive clustering is known as top-down approach. So from the root element, it goes leaf part. Okay. See here, it follows the top-down approach. It begins the whole set of data points, and it will proceed to divide into successively. So division is made successively to form a smaller number of clusters. So each individual elements will be formed. So each individual elements is going to be called as a each cluster. So that methodology is divisive clustering. That is, it follows the top-down approach. Okay. Next, coming on to the next type of partitional clustering, K-means and fuzzy Z-means. So K-means algorithm is nothing but a division of objects into clusters. So each object will be in exactly one cluster, not in several clusters. Okay. So in case of fuzzy C means, it is also dividing the object into clusters such that each object can belong to multiple clusters. So let's see how the hierarchy clustering works. Okay. So the steps included are, first we have to measure the distance, and grouping is made or based on the distance measure, and finally you have to terminate the process. This is what the hierarchical clustering works. Okay, consider we have few points on the plane. So here there can be a plots P1, P2. There are 6 data points are there on the plane. Okay, P1 starting from P1 it goes to P6. Okay. Now each data point, consider each data point is a cluster of its own. Now we try to find the least distance between the two clusters, or we can say two data points. Okay. Okay. Now let's see P1 and P2. So this is having the minimum distance between the two data points P1 and P2. Okay. Okay. So these are the two nearest data points or merged together. Okay. Now this is these two P1 and P2 are represented like a tree-like structure called, this is called dendrogram. Okay. So upon plotting, we have group P1 and P2. With this group, you have represented the tree-like structure called dendrogram. Okay. Next, you are forming another cluster P3 and P4 data points are merged together, and the dendrogram is depicted here. Next, P5 and P6 were grouped together to form another cluster. So 3 clusters are formed. Now, again, you can go up with grouping the 2 clusters. So green cluster will combine P3, P4, P5 and P6, and the dendrogram is depicted in the picture, tree-like structure, okay? And finally it forms a whole group. See here? So this what a hierarchical clustering works. So how do we terminate, so whenever you form a single cluster, at that point you have to terminate the clustering process. Okay. Then how do we measure the distance between the data points? Okay. So you need to find the distance measure. So this will determine the similarity between the 2 elements, and it will influence the shape of the clusters also. Okay. So how do we measure? So this similarity is subjective to change, okay, and this measure is therefore depends on the data, use case, and the users. Okay, and there are mainly this matrix will work well in the base of trial and error. So the examples of similarity measures are Euclidean distance measure, Manhattan cosine distance measures, and distance, squared Euclidean distance. And these are the formula to find the distance similarity measures. Okay. See here, there are 4 distance measure are there. Okay. So Euclidean distance measure, squared Euclidean distance measure, Manhattan distance measure, and the last one is cosine distance measure. So first we will see the Euclidean distance measure is ordinary straight line drawn, and this is see here the plot is between x and y axis. You are going to plot P and Q data points on this plane. Okay. So now find the distance between the P and Q with the help of this Euclidean formula, distance formula. That is the summation of all the data points and the difference between the 2 points and squared on those points. Okay, you will get the distance between 2 points in the Euclidean space. Next, squared Euclidean distance measure means removing the, you need not to go for taking the square root. Okay, so this Euclidean squared distance metric uses the same equation as that of the Euclidean distance metric, but does not take the square root. Coming on to Manhattan distance measure is simple sum of the horizontal and the vertical components, or the distance between the 2 points measured along the x-axis at right angles. Okay, and this is the formula to calculate the distance, Manhattan distance measure. Similarity measures the angle between the 2 vectors, and the formula is given. Based on this, you have to find the measure. Okay. So next, what is the agglomerative clustering? So this is one type of hierarchical clustering. Okay. So there are 3 questions, that needs to be answered. First question is, how do we represent a cluster of more than 1 point? The second one, how do we determine the nearness of the clusters? And third one, when to stop combining the clusters? Okay. For example, if you take the 6 data points in Euclidean space means, and second, how do we represent the cluster of more than 1 point? Okay, we can go for make use of the centroids, which is the average of the data points. Okay, see here, 1, 2 and 2, 2. We can find the centroid of these 2 points, and you can go get the centroid as 1.5, 1.5. So based on this, finding the centroid of the 2 between the 2 data points, you can form a cluster. Fine. And you can also draw by drawing the tree-like structure called dendrogram. See here, you can form a group, another cluster, 4, 1 and 5, 0 can be can form a cluster based on the centroid by finding the centroid 4.5, 0.5. Okay, and the other thing nearing to that first cluster is 0, 0. Then among the first centroid 1.5, 1.5, with that of the 0, 0, you can form a new centroid that is 1, 1. Likewise, in with this cluster also you can find the 5.5, 3. Okay, so with this you can find the new centroid with that of the 4.5, 0.5. You can find the new centroid at 4.7, 1.3. So from this grouping of data points, we can draw the dendrogram. Okay. So when to stop combining the clusters? Okay. There are many approaches to stop combining the clusters. The first approach is you have to need to pick up the number of clusters, that is k. Okay. So k is nothing but it is representing the number of clusters you choose. Okay. So we decide the number of clusters required in the beginning and we terminate when we reach the value of k. Okay. So there are so many possible challenges. That is, we need to know about the data very well. Okay. Let's consider the value of k is 2. So in our previous example, we stopped when we are left with the 2 clusters. Okay. If you are setting the value of k is 2, you can stop combining the clusters achieving 2. Okay. The second approach is to stop the clustering is stop when the next merge would create a cluster with the low cohesion. So what is meant by cohesion? So cohesion is a measure which determines how closely the objects are related in a cluster. That is called as cohesion. Okay. So we keep clustering till the next merge of clusters creates a low cohesion or bad cluster. Okay. But how this cohesion is defined means it determines how the objects are very close to each other in a cluster. That is called as cohesion. Okay, the next approach is finding the diameter of the cluster. So diameter means it's the maximum distance between any pair of points in the cluster. Okay, so we terminate when the diameter of the new cluster exceeds the threshold. Okay. And the next approach to stop the clustering is radius of a cluster. So radius means it is the maximum distance of a point from the centroid. Okay, and we terminate when the radius of the new cluster exceeds the threshold. Okay. Next, coming on to the divisive clustering approach, it begins with the whole set of the data points or data elements and proceeds to divide into further smaller clusters. Okay. So it starts with a single cluster composed of all the data points, and second step we have to go for dividing the all the data points into different clusters. So this can be done using monothetic divisive method. Okay. So what is monothetic divisive method? Okay, let us consider an example. We took it in the aggregative clustering. Okay. We have considered 6 data points in the plane. Okay. Now we name each point in the cluster A, B, C, D, E. Okay. 6 points. Shall we follow the top-down approach in the divisive clustering? Okay. So top-down approach means now we have to take up with all the data points A, B, C, D, F, and you can go by dividing into 3 clusters. Like one cluster combining having A, B, and the other cluster C, D, E, F. And the next possibility we can go for forming B, C, E, and the other cluster A, D, F. Likewise, you can combine in 3 approaches. Okay, obtain all possible splits into 2 clusters. Okay, So that's all about hierarchical clustering. In that, we have seen one is agglomerative clustering, which follows the bottom-up approach, and the next one is divisive method, which follows the top-down approach. Next one is k-means clustering, which comes under partitioning clustering algorithm. So what does k-means? It performs the division of objects into clusters which are similar between them and which are dissimilar into objects belonging to another cluster. That is, it can go for dividing the objects to form a similar object into one group and dissimilar objects into another group. Okay. So K here represents the number of clusters that you are going to form it. Okay. So this how the k-means clustering works. So first, while starting the process, we need to go for calculating the elbow point, that is K. Okay, K means it is going to find the number of clusters. Okay. Next, we need to go for measuring the distance. Okay, and grouping is to be done based on the minimum distance achieved. Okay, then reposition the centroids. Okay, so if the clusters are stable, then we can so that it can go for convergence. If the clusters are unstable, then we can again repeat the same process, measure the distance, then group the data objects based on the minimum distance and relocate the centroids. So again, you have to repeat all these processes if the clusters are unstable. Okay. Okay. So first you need to find the elbow point. Let's say you are having the data set for a grocery shops. Okay. So how do you choose the optimum number of clusters? Okay. So the best way to do the number of clusters is that elbow method. Okay. So the idea of the elbow method is to run the k-means cluster on the data set where k is referred to as the number of clusters. So how do you find the number of clusters? With the formula called WSS, that is within sum of squares. So which is defined as the sum of square distance between each member of the cluster and its centroid. So the formula is given. By substituting this formula, you could find the sum of squares. Okay. So here in this formula, x represents the data point and c represents the closest point to centroid. Okay. So with this, you could plot the graph between the number of clusters and the within sum of squares WSS. Then you could find the value of that is number of clusters k value as 2. That we call it as a elbow point. Okay. So now we draw the curve between WSS, that is within sum of squares, and the number of clusters. So here we can see a very slow change in the value of WSS after k value after k equals 2. So you should take the elbow point value as the final number of cluster as k equals 2. Next, the first step is there are given data points below or known as delivery points. Okay. Now we can randomly initialize 2 points that we call it as a cluster centroids C1 and C2. Okay. So now find the Euclidean distance between the data points. Okay. Euclidean distance is the distance measure used to find out which data point is closest to the centroid. Okay. By applying the formula, you have to calculate it. Okay. And the next step, based on the distance from C1 and C2 centroids, the data points will be grouped itself to form a clusters. And fourth one, compute the centroid of data points inside the blue cluster. And for fifth point, you have to relocate or reposition the centroid of the blue cluster to a new centroid. And next thing, now move on to the next cluster, that is C2. Compute the centroid of the data points inside the orange cluster. And then relocate the centroid of the orange cluster to a new centroid. Sorry for the inconvenience, been disconnected. Okay, still 2 more slides are there. Let me complete it. Okay, fine. Okay, K-means algorithm. We are having a first step we need to do if you are given x3 and the value of k. So k is nothing but the number of clusters to be determined. Okay, and first step you need to do is you have to pick up a value that is random point that is called the centroid. Okay. And the second thing you need to do is assign each x to the nearest cluster by taking distance to each centroid. Okay. And third step, you need to find a new cluster center by taking the average of the assigned points. Fourth step, you have to need to go by repeating the step 2, 3 until none of the cluster assignments change. Okay. So the process is given here. Okay. The first step, you need to centroids. The second step, you need to assign you need to calculate the equidistance by using the formula. And third step, you have to find the new centroid by using the formula by taking the average of all the points assigned to the cluster. Okay. Fourth step, you need to go by repeating the 2 and second step. Okay. And these are the applications of K-means algorithm. You can go for calculating. You can apply this K-means clustering algorithm, and for diagnosing the medical diseases, anything whether a person is having a cancer or a normal person, you can diagnose using this K-means clustering algorithm, and search engine all these fields you can go for applying the K-means clustering algorithm. So with this, I'll wind up the today's session. Thank you for patient listening. Okay. Thank you, Padmani, Joshika. Thank you, Tarni. We'll wind up the session. Okay. With this, I have completed classification algorithm. Thank you, Tarni. And classification algorithm.